Good morning. This is very important question. We need to compute a power 100 for this matrix, the 2 by 2 matrix. So for that, first we write the characteristic equation to get the eigenvalues, and then we are going to get the eigenvectors. So the characteristic equation is lambda I minus a, the determinant is equal to 0, where this I is the identity matrix of order 2. So we get lambda into 1 0 0 1, this identity matrix, minus this a. So from here we get lambda minus 1, then minus 4, then minus 3, and then lambda minus 2, taking its determinant to be equal to 0. So now finding the determinant of this, so we have to cross multiply these two. So this is the product of lambda minus 1 and lambda minus 2 minus, multiplying minus 3 and minus 4, we get 12. So from here we get lambda square minus 3 lambda plus 2 minus 12 equals to 0. And this is minus 10. Writing the factors for this. So this is lambda minus 5 into lambda plus 2 equals to 0. So from here we are getting lambda equal to 5 and negative 2. So these are the two eigenvalues we are getting. So we have got one eigenvalue to be minus 2 and another one to be equal to 5. Now finding the eigenvectors corresponding to these eigenvalues. So when lambda 1 is equal to minus 2, what we get? So for that we must write the homogeneous equations for this. That is lambda 1 I minus a into the vector x equal to 0. Right? So we have already found this. That is this one. And we need to put lambda 1 to be equal to minus 2 in place of lambda. Right? So we get here minus 3 minus 4 minus 3 minus 4. So this is minus 3 minus 4. And again minus 3 minus 4. An x vector, writing the components x1, x2, and then here 0 0. Now we are going to get the homogeneous equations for this. Multiplying minus 3 with x1, we get minus 3x1, plus multiplying minus 4 with x2, we get minus 4x2 to be equal to 0. Similarly, the other equation would also be same, minus 3x1 minus 4x2 equals to 0. So both the equations are same. So from here we get 3x1 plus 4x2 equals to 0. That is 3x1 equal to minus 4x2. Right? If I take the value of x2 to be equal to t, where this t is belonging to the set of real numbers, I will be getting 3x1 to be equal to minus 4t. And the value for x1 is minus 4 divided by 3 into t, right? And the value of x2 is itself t. So now writing the eigenvector for these values. So writing x1 to be minus 4 by 3 into t. And the value of x2 is t. If I take t common, I will be getting this minus 4 by 3 and 1. Where t is belonging to the set of real numbers. If I take the value of t to be equal to minus 3, what I get? I get eigenvector x1 to be equal to, what is the first element of this column vector? It is 4, and the second is minus 3. So we have got the first eigenvector x1 to be 4 minus 3. You can give any value to t to get so many eigenvectors. So right now I have taken this eigenvector, and now calculating the another eigenvector corresponding to this eigenvalue. For that we must write the homogeneous equations first. So lambda 2 I minus a into x is equal to 0. So writing x as x1, x2 in the column format, and this is 0 0. And for this, let's put lambda 2 equal to this time 5 in place of lambda, and we get this to be 4 minus 4 minus 3 and then 3. So this is 4 minus 3 and 3. So from here the homogeneous equations we get 4x1 minus 4x2 equals to 0. And similarly the other one, minus 3x1 plus 3x2 to be equal to 0. Both these equations are same. So from the first equation we get 4x1 to be equal to 4x2. That is x1 is equal to x2. If you solve the second one, you will be getting the same. It is minus 3x1 to be equal to minus 3x2, or x1 is equal to x2. So we are getting the same relation for x1, x2. That means if I give the value x2 to be equal to t, where t is belonging to the set of real numbers, I will be getting the values of x1, x2 both to be equal to t, right? So now writing the eigenvector, what is x1? It is t, and x2 is also t. If I take t outside, I will be getting 1 and 1, right? For t belonging to the set of real numbers. If I give the value t to be equal to 1, I will be getting the eigenvector x2 to be 1, 1. Right? So now writing the P matrix. So for that we are filling the eigenvectors over here. What is the first eigenvector? It is 4 minus 3. Writing this in column format. So this is 4 minus 3. The another eigenvector is 1, 1. Writing this in column format. So we have got our matrix P from these eigenvectors, right? And now to find the value of P inverse, please find this yourself. So when finding this, we get this to be 1 by 7 multiplied with the matrix, the 2 by 2 matrix, and the elements are 1, 3, minus 1, 4. Such that P inverse AP is a diagonal matrix, right? So when you multiply P inverse with A and further the result with P, you will be getting the matrix to be minus 2, 0, 0, 5, which is your diagonal matrix, isn't it? Very fine. Okay, so from here we get the value of A now. If I first pre-multiply this with P and then post multiply this with P inverse, I will be getting the value of A to be P into this matrix minus 2, 0, 0, 5, and here P inverse. Is it okay? Fine? Yes. And now finding the required value, that is A power 100. So this will be equal to P into taking the power 100 to the elements of this matrix. And this is 5 the power 100. And here P inverse. And now writing the values of P and P inverse. What is P? It is 4 minus 3, 1, 1. Writing this matrix the same as it is. And P inverse is, I am writing here 1 by 7 for P inverse and the remaining matrix. So this is equal to 1 by 7 into writing this matrix as it is and multiply this matrix with this. So this is minus 2 the power 100 multiplying the first element with 1 plus multiplying the second element with this. So that is 0, right? And then multiplying this element with this. So this is 2 the power 100 plus multiplying this 0 with 4, that is 0. And then multiplying 0 with 1, that is 0, plus multiplying 3 with 5 power 100. So this is 3 into 5 power 100. Similarly the last one, multiplying 0 with minus 1 plus multiplying this with 4. So that is 4 into 5 power 100. Very fine. Similarly we have to multiply this matrix with this. So for that just multiply 4 with this first element plus 1 with the second element. We get 1 by 7 into minus 4 into 2 power 100 plus 3 into 5 power 100. To get the second element, multiplying 4 with this plus multiplying 1 with this. So we get here 4 into 5 power 100 plus 4 into 2 power 100. And then multiplying minus 3 with this plus 1 with this. So this is 3 into 2 power 100 plus 3 into 5 power 100. And similarly writing the last one, 4 into 5 power 100 minus 3 into 2 power 100. That doesn't matter if you interchange. So this is how we get the value of a power 100. Okay, thank you. Stay blessed.